you by thesis123.com. I learn and teach online.
Here's the next question, number 41. A 30 MVA 3-phase 50 Hz 13.8 kV star-connected synchronous generator has positive, negative and zero sequence reactances 15%, 15% and 5% respectively. So positive is 15, negative is 15, zero sequence is 5%. A reactance Xn is connected between the neutral of the generator and ground. A double line to ground fault takes place involving phases B and C with a fault impedance of J.1 per unit. The value of Xn in per unit that will limit the positive sequence generator current to 4270 amps is dash 4270 amps. Okay, so this isn't a multiple choice question. We will have to work it out the best way we can. Okay, so the first thing we do is we have been told the synchronous generator is star connected. So I'll just draw a rough diagram here. Now let's assume that the positive sequence XA, and then we have, let's call that X1, X2 and X0. So that's B and C, we'll call that A. And at neutral we have Xn, which is grounded, and there is a double line to ground fault which takes place involving phases B and C. Now this should tell us, let me just underline that, involving phases B and C. Now this should tell us that XB becomes parallel with XC since both of them are grounded. So this is an important point. Let's keep that in mind. Now the next thing is, let's find out what the current, base current is. Now you should know that we always need a reference value. So we have to calculate the base current. I'll just write down what is already given to us. X1. Now it says that the positive is 15% positive sequence reactance. So let's write that as X1 0.15 pu. Now it's in percentage, so we convert it and write it as 0.15 pu. Similarly, negative sequence X2 is written as 0.15 pu. Zero sequence X0 is written as 0.05 per unit. And next, what else do we have here? Fault current. Now it's been given that a fault impedance is given as J.1 pu. So let's consider that as XF, or fault reactance. Fault reactance is J.1 pu. Now I base, the base current, the formula is MVA base divided by √3 times kV base. So using the values that have been given in the question, we have MVA given to us, that's 30 MVA over here. So that's 30 into 10 power 6. We have to be careful with the units as well. Divided by √3 into kV. So the value over here is 13.8 kV. So we add that, we write that down here, 13.8 into 10 power 3. Now solving this, we'll get our base current as 1255.109 amps. This is base, so we write it in terms of per unit. Okay, so now we have our base current. The next thing we need to find is the current as the positive sequence with respect to the base current. So let's find out the positive sequence current. I'll just take another piece of paper here. Okay. So we need I01. I'm going to consider it as I01 0.01, or in fact let me write it as IA1. So that's our positive sequence current with respect to the base in per unit, and the relationship with the base current is I actual divided by I base. So I actual is the value that has been given in the question, 4270, divided by the value that we just calculated, 1255.109, and when we divide that, we get the value to be 3.4 per unit. Okay, so now that we have the value of the positive sequence current, let's write down the equation of positive sequence current, keeping all the reactances in view for a double line to ground fault. So we have IA1 is equal to EA divided by X1 plus, now here we'll have to be careful, X2 parallel to X0 plus 3 times XF plus XN. Now this is the general equation that you will have to remember. This is for 3-phase. Now that's another point. Now 3 times the fault reactance plus the reactance that has been added to the neutral, you will know that this is the formula we will need to use for a 3-phase system. Now we have the values of IA1, that's what we have just found. We consider EA to be 1 for per unit value. X1 has been given to us as 0.15. X2 is also given to us as 0.15. X0 as 0.05. XF is given as 0.1. And Xn is what we need to find. So we plug in all the other values and just solve for Xn. So let's see what we get over here. So we have IA1 is equal to 1 divided by X1 is 0.15 plus 0.15 into, now this is parallel, so you'll have to remember your formula when two things are parallel, right? So basically it's R1 parallel to R2 would be written as R1 R2 divided by R1 plus R2. So we use the same formula here. Please be very careful because the terms are quite large. So that's 3xn plus 0.3 plus 0.05 divided by 0.15 plus 3xn plus 0.3 plus 0.05. Now I have expanded and substituted the values as well. This is 3.4, so let me just put that in here in the next step. So that's 3.4 is equal to 1 divided by 0.15 plus 0.15 times 3xn plus 0.35 divided by 0.15 plus 3xn plus 0.35. Okay, so I leave the most of the solving to you because this is basic algebra. You'll have to cross multiply and then take the common denominator and then solve for xn. So you will know that after solving, your value for xn comes to 1.08. So please solve the rest of that portion and check if your value matches with 1.08. Here is the final answer. I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+, and Pinterest.